Hello everyone, welcome to Numeric Ninja. Today we are going to discuss a problem which is as follows. Evaluate NC0 minus NC2 plus NC4 minus dot 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 whole square plus NC1 minus NC3 plus NC5 minus dot 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 to whole square. Now the last term of both the expressions will be determined whether n is even or whether n is odd. And it is given to the user to just look up into the pattern and solve this problem. Now, to solve this problem, we are going to use the binomial theorem, which gives us the expansion of x plus y whole to the power n. And it says that x plus y whole to the power n is nc0 times y to the power n plus nc1 times x times y to the power n minus 1 and up to ncn times x to the power n. Now, why do we get the motivation of using the binomial theorem? Because we can see that in the question, we are given the binomial coefficients. So these are the binomial coefficients. And whenever there is a problem regarding binomial coefficients, we try to link that problem with the binomial theorem. And here we are going to do the same thing. Now, a very special case of the binomial theorem is when we put y equals to 1. And this is very useful when we are dealing with such kind of problem which involves the binomial coefficients. So if we put y equals to 1, we'll get x plus 1 whole to the power n is same as nc0 plus nc1 times x plus nc2 times x squared and up to ncn times x to the power n. Now, if you remember that the binomial theorem is true for any x and y because it's an identity, and since it's an identity, we can take x and y to be complex numbers because it's true for any x and y. So we can even put x as a complex number. Now, why do we get the motivation of using the complex number? Because if you look at the expression, let's copy this expression over here and paste it down here. Now, if we take a look into these two expressions, we can see that the coefficient of NC2 here is minus 1. And in this case, it's x squared. So x squared can only be equals to minus 1 if x equals to I. It's a case. So if x equals to I, then x squared is equals to minus 1. So with this, if we put x equals to I in this expression, we will get x equals to I. We get I plus 1 whole to the power n is same as nc0 times n plus nc1 times I plus nc2 times I square up to ncn times I to the power of n. Now, if we just write up more terms here, we will get it same as nc0 plus nc1 times I plus nc2 times I square plus nc3 times I cube plus nc4 times I to the power 4 and up to ncn times I to the power of n. Now, if we just put I square as minus 1 and I cube as minus I, we will get the same as nc0 plus nc1 into I. This will become minus nc2 because I square is minus 1. And from here, we'll get that nc3 will become minus nc3 times I because I cube is minus I plus nc4 and it continues and it becomes nc4 because I to the power 4 is 1. And we don't know the last term because we don't know whether n is even or whether n is odd. So we will not be writing down the last term. Now, if we arrange these terms as real and as complex with I, we get this is same as nc0 minus nc2 plus nc4 and it continues. It must be a minus if you guessed, and plus nc1 minus nc3, and after this it will be plus nc5 dot 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 with multiplied with an I. Now, if we look up very close, that this is actually, if we call I plus 1 whole to the power n as a z, then we can say that this is actually the real part of z, and this is actually the imaginary part of z, and here is z refers to 1 plus I whole to the power n. Now, and this is what we were needed to find. If we compare these two terms, let's paste it over here once. If we compare that, what we were needed to find is actually, we are needed to find a real part of z whole square plus imaginary part of z square. So this is very interesting because we know this is actually the modulus of z square. Because if we have z equals to, if we have z equals to a plus ib, then we know that z is equals to, mod z square is equals to a square plus b square, and here a is the real part of z and b is the imaginary part of z. So we can see from here that if z is equals to I plus 1 whole to the power n, then the modulus of z square is basically the modulus of 1 plus I whole to the power n, and this mod square. And from here we can say it's basically I plus 1 whole to the power 2n. Because we know that, why put write it? Because we know that z1 times z2 whole mod is actually equals to modulus of z1 times modulus of z2. Now going back to this, and what is I plus 1, this modulus? This modulus is 1 square plus 1 square whole to the power of 2n, and this is basically 2 times 2n, and this square root will become by 2, so this is basically 2 to the power n. So this expression over here is basically 2 to the power n, and hence the answer is 2 to the power n, and the option is A. I hope you enjoyed the video. If you did, please give it a thumbs up. Please subscribe to my channel. Feel free to suggest any other alternative solution in the comment section. See you in the next video.